today we'll see the psychrometric chart. So first we'll understand what is psychrometric. So the science that studies the properties of moist air and the process in which the temperature and or water vapor content of the mixture are changed. So in psychrometric we can study the different properties of the moist air. So moist air nothing but the air which contains water vapor. So if there is a mixture of this water vapor, so air always contains some water vapor. So these different properties we will study in psychrometric, and the process in which the temperature or water vapor content of the mixtures are changed. So if the temperature and water vapor content, if it changes, so that everything we will study in the psychrometric chart. So for example, if you take 25 degrees centigrade temperature and water vapor content nothing but a humidity is 50%, so then what is the rest of the properties of air? So what will be the dry bulb temperature, or what will be the wet bulb temperature, what will be the humidity ratio? So these are related to the properties of moist air. So, okay, so that we will see it in the psychrometric chart. Okay, so what is psychrometric chart? It contains relations between properties of moisture air. So in psychrometric chart, we can see the all relations that is related to properties of air. So for example, dry bulb temperature, wet bulb temperature, relative humidity, humidity ratio. So these all are properties of air. So that all will contains in the psychrometric chart. Okay. So first we will understand what are the properties of air definitions, and we'll go to psychrometric chart. So first one is dry bulb temperature. So the temperature of surrounding air is called dry bulb temperature, indicates sensible heat. So temperature, so wherever we are, so whether it is in room or outside environment, everywhere, so the temperature surrounded by us is called as a dry bulb temperature. Okay, so for example, we'll say like today it is very hot. So today the temperature is 40 degrees, 35 degrees centigrade. So that temperature is called as surrounding temperature. So that we call, the term we call as a dry bulb temperature. It indicates the sensible heat. And also we can see the right side second image, TDB. TDB nothing but temperature of dry bulb. Okay, so it is measured with an thermometer. Next one is wet bulb temperature, measured by an ordinary thermometer when its bulb is covered by a wet with cloth, indicates humidity content. Okay, so this wet bulb temperature also measured with an ordinary thermometer, but this bulb, so here you can see the bulb which is covered with a wet cloth. So we have covered with one wet cloth, and then we check the temperature. So when we do this, so that temperature we call it as a wet bulb temperature. So why we are uh, like covering with a wet cloth, and why we are measuring the temperature? For example, so when we uh, wet this cloth and we measure the temperature, so we'll get the wet bulb temperature. So wet bulb indicates that how much fastly the evaporation is happening inside. So for example, if the saturation, like if the humidity content, so we know that air contains some moisture. Okay, so in our last class we discussed that if moisture content is 100%, so the water vapor is 100%, so then we can say it as a saturation point. Okay, so if this saturation point for example, if we got the saturation point in the atmosphere, so then what will happen, the dry bulb temperature and wet bulb temperature will be match. Okay, so this wet bulb temperature indicates that how much fast the evaporation is happening. So it depends on the moisture content present in the air. Okay, for example, if the moisture content in the air is 30%, then evaporation will be high. Why? Because the air can hold the another 70%. So if the moisture content is 90%, so the evaporation rate is very less. Okay, so there will be only the 10% moisture can hold the air, so that the evaporation will be less. So in simple words, we can say that wet bulb temperature is used to uh, indicates the how much fast the evaporation is happening. Okay, so when we wet the cloth and we will tie it with the thermometer, so the wet cloth will contain some water, that is the moisture. So it will based on the humidity present in the atmosphere, the moisture, the evaporation will be happen. Okay, so that is wet bulb temperature. Next one is dew point temperature. So temperature at which vapor condenses to liquid. So we discussed that dew point temperature, operative dew point or dew point temperature. What will happen? The temperature at which vapor condenses to liquid. So we discussed that in our last class also. When we cool the air, so the outside air is 32 degrees or 35 degrees for an example. So we are cooling the air with our air conditioning equipment. So at reaching the certain point like 15 degrees centigrade or 18 degrees centigrade, so the air will start, the vapor will start condenses to liquid. Okay, so that's why we are getting the water from our AC units. So if you have anybody else using the split ACs or any other ACs, so there will be a droplets of water continuously coming from the unit. So that is called a condensation. Okay. So due to the low temperature, so the vapor will come condense to the air which is coming from the outdoor. It condenses to liquid. Okay. So next one is relative humidity. Relative humidity equal to amount of moisture present in sample of air by amount of moisture present in saturated air. Okay. So this is nothing but relative humidity is the amount of moisture present in the air. So for example, uh, if the humidity is 50% or if the humidity is 80%, so we can say that the moisture content present in the air, that is 50% or 80%. So it is just a amount of moisture which is present in the air, that is called a relative humidity. So the formula, we can say amount of moisture present in a sample of air divided by amount of moisture present in saturated air. Okay. Next one is humidity ratio. Grains of moisture present per pound of dry air. Okay. So if you take 1 pound of dry air, so how many grains of moisture is present in that pound of dry air? Okay, that we call it as a humidity ratio. So generally we measure that in grains. 1 grain equal to 0.0648 grams, or 1 lb equal to 453.6 grams. Okay. The next one is enthalpy. Enthalpy, nothing but total heat content in the air. So how much heat is contained in the air, that we call it as a enthalpy. So we will see the psychrometric chart. So in psychrometric chart we can uh, we can measure the following properties and also the solve the problems related to moist air. So first we will see graphic presentation of the properties of air. So the psychrometric chart with the comes with all these whatever definitions we have seen: dry bulb, wet bulb, relative humidity, humidity ratio, enthalpy. So that representation lines will be there in the chart. And also second in used to solve process problems with moist air. So also we can solve the process problems which comes for the moist air, and also heating and cooling. Fourth one, humidification and dehumidification. So these are the uh, different types we can use and we can derive in the psychrometric chart. So this is called the psychrometric chart. So this is how it will look. So in this image we cannot see the lines properly. So I have highlighted the individual every point, like dry bulb, wet bulb, every point I have highlighted in separate images. I will show that. So this is called dry bulb lines. Okay. So if you take any chart, so the dry bulb lines will be like this, vertical lines, and it will start from uh, 0 degree Fahrenheit to it. In this chart we have 120 degree Fahrenheit. So this is the dry bulb lines. So this is all wet bulb lines, slanted lines. Okay. And 30 degrees, 40 degrees, till here 90 degrees it was shown. And this is dew point temperature. Okay. On the horizontal lines, so which is indicating the dew point. And these are the relative humidity lines. Okay. So slightly curved lines. Okay, it is from 0 to 100%. Okay. And next is humidity ratio. So humidity ratio also horizontal lines. We can say from 0.0042 to 0.028. This is the enthalpy lines. These are the slanted lines. Okay. Okay. So we have seen the different lines of the properties of air. So I will show the psychrometric chart. Yeah. Okay. So I will enlarge this and I will show the all properties of air which we have seen in the PPT. So you can see here, this is the dry bulb temperature, and this is the lines 20, 25, 30, 40, 50, 60, 80, 100 and till 120. So next one is wet bulb temperature. So we can see these are the wet bulb lines: 85, 80, 75, 70, 65, 60. Okay. So till we have 25. Next is relative humidity. So this is a curvature line, you can see. This is a relative humidity. It's also relative humidity 30, 40, 50, 60 till the 100. Okay. And enthalpy lines are this one 13, 13.5. No, this is the enthalpy lines. This is the scale, outer scale, black side, black we are seeing, right? This is the enthalpy line. Okay. So 20, 25, 30, 35, 40, 45. Okay. And also after this, we have in the right side, this is humidity ratio starting from 10, 20, 40, 60. So like this we have. And dew point temperature minus 20, 0, 10, 25, 30. Like this continue. Okay. So we will take one example and we will solve with that in the psychrometric chart. Okay. Okay. So for editing this, I am uploading just this to the AutoCAD so that I can easily edit. So you people, you can take the printout and mark with the you can take printout and do the calculations. Okay. Okay. So the nothing is different. Same thing, same PDF I have uploaded here so that I can easily edit this. So here we have some examples. So we'll do that. So remember that whenever we are doing the psychrometric calculation, so we will get only the two values, whatever that may be. Okay. It may be dry bulb, wet bulb, or dry bulb relative humidity. So two values we will get it. Okay. So this psychrometric chart is very useful when we are calculating heat loss. So uh, try to solve this all psychrometric problems. Okay. So here first problem is if the dry bulb temperature is 104 degree Fahrenheit and the relative humidity is 24. Okay. So this is the two values we got. So remember every time we will get only the two values uh, so that we need to calculate the rest of the values. Okay. So for this, here we got dry bulb temperature of 104 degree Fahrenheit and the relative humidity of 24. Okay. So also remember here the units also important. Okay. So we have taken dry bulb in degree Fahrenheit and humidity is always percentage. There will be no change. But wet bulb also Fahrenheit, dew point temperature also Fahrenheit, and humidity ratio in grains per LP. Okay, and enthalpy in BTU per LP. Okay, so if you change the unit, one unit, and you are doing something, so that will be make some mistakes. So remember, if you are working in a Fahrenheit, so then all the rest of the values should be like this. Okay, so first what we will do, we will mark the dry bulb lines and relative humidity lines. Okay, so dry bulb at, so what is our dry bulb value? 104 degree Fahrenheit. So I will mark this 104. So this is the dry bulb lines where is 104. Okay, 104, it is nearby 105. So here we need to mark. So I will take one line. Okay, this is the wet dry bulb line. So Okay, this is the dry bulb temperature. So next value we got here, it is relative humidity of 24%. So relative humidity lines we know this is 10%, 20, 30. These are the relative humidity lines. So our value is 24%. Okay. So if you take this 24% in between 20 and 30, so I will take one line. Okay, we'll draw one more time. 24% relative humidity. Here I am taking. So here I will add. Okay. So if you see these two lines are meeting in this point. So we can find out the rest of the properties of air by using these lines. Okay. So what is the values required here? So next first one required is wet bulb temperature. So wet bulb temperature lines are these lines. Okay. 85, 80, 75, 70 and 65. So these two lines are meeting here. So what I will do? I will draw one line in a axis of wet bulb. So these two line was meeting here. So I will keep this line here like this. So I will extend this. Okay. So what is the wet bulb here? 85, 80, 75 and 70. So this 70, 71, 72 and this is 73. So the wet bulb is 73 degree Fahrenheit. And next one is dew point temperature. So where it is dew point temperature lines are here. So this is a dew point temperature line. So we need to draw a straight line in a horizontal. So from this point, so all the values we need to take it from this with these 2 points where it is meeting. So that point we need to take all the values. So we'll draw one straight line. So with this straight line we will get two values. So first one is dew point temperature. So the dew point temperature is 58 or 59. So I'll take 59. So you will understand that in by this chart the dew point temperature. So when the relative humidity is 24% and the dry bulb is 104 degree Fahrenheit, so the dew point will be 59. So the dew point, you will know that the vapor will condense to liquid. Okay. So at this point, the vapor is condensing to liquid. Okay. And humidity ratio. So this is the humidity ratio lines. So we can get it here. So that is 72 grains. Okay. 72. So why? Because we are not drawn already. The line is there. So this is the axis of humidity ratio. So it is meeting at 71 and 72. So we can take it. Right. And next one is enthalpy. Okay, enthalpy lines are these lines outside scale. So we have already drawn one line. So with the help of the line, we can take these values. So here it is 30, 35, and 36, 37, 38, 39, 40. So we can take that as a 37 enthalpy. Okay. So this is how we will calculate the psychrometric calculations. Okay. So I will give the assignment for everyone. So I have solved one problem. So second, third, and fourth, these three I will give you. So please try to practice and submit the assignment tomorrow. Okay. So I hope everyone has understand the psychrometric. So if anyone has not understand, please tell me. I will tell it again.